Hi ladies and gentlemen, I would like to welcome you back to Science Explained with Mr. K. Today I am going to cover electrochemical cells, and to those that do not really understand this topic, I hope that I'm going to highlight some of the aspects that are very important that you need to know about this topic. Enjoy. Right, today ladies and gentlemen, we are going to look at electrochemistry. What is electrochemistry? Electrochemistry, it is a study that involves transferring of electrons from one substance to the other. That is electrochemistry, okay? And then in this topic, we have terms like oxidation. What is oxidation? Oxidation, it is a process that involves loss of electrons. Okay, I want you to understand me fully. It is a process that involves loss of electrons. Okay, and then when you talk about reduction, it is a process that involves gaining of electrons. I know it's weird because some people are expecting reduction to be loss, right? You're losing something. As a result of that, it becomes reduction, right? You are reduced. But in this case, I want you to understand that an electron is negative, and every time when we gain an electron, we are being reduced. Hence, the process is called reduction. It's reduction in a sense that every time when I gain an electron, because an electron is negative, then I'm being reduced. And then, ladies and gentlemen, we have a term, oxidizing agent. Okay? Remember, there's a difference between oxidation, meaning a process, and an oxidizing agent. The moment you see the word oxidizing agent, right, it means a substance, a particular substance. Okay? Now, what is an oxidizing agent? Okay? An oxidizing agent, it is a substance that gains an electron. It is a substance that gains. In other words, this oxidizing agent, it causes the other substance to lose so that it can gain. So an oxidizing agent is a substance that gains electrons, okay? So meaning the reducing agent, I'm now talking about a substance. I want you to understand, guys, it's not a process, but a substance. A reducing agent is a substance that loses an electron, okay? The oxidizing agent is a substance that gains whilst the reducing agent is a substance that loses an electron. I want you to get that right. Right. So another thing that I want you to take note of, guys, is that these two processes, when I talk about oxidation and reduction, these two processes, they happen at the same time, simultaneously. When the other substance loses an electron, the other substance is readily available, in other words, to accept that particular electron. Okay? And then I want you to look at something else. Now, as soon as you're losing an electron, I want you to understand that originally, as an element, you are electrically neutral. You have equal number of protons and electrons. I want you to understand that, guys. When we say something is electrically neutral, we say that it has equal number of protons and electrons. Is that clear, guys? Now, as soon as I lose an electron, what does that mean? That means I will have more protons than electrons. Do you get what I'm saying to you? That means I become more positive. And for the fact that I become more positive, now I'm going to say the oxidation number increases because I am moving from being neutral, meaning 0, to a positive 1 or positive 2 or positive 3. I want you to understand. Okay, as soon as I lose an electron, that means I am increasing in the oxidation number. Okay, at the same time, I want you to understand this. When you are gaining an electron, say you were neutral, meaning you were 0. Okay, once you gain an electron, you become more negative. Why? Because there's more number of what? Of electrons than protons. So you become more negative. Okay? So think about this. So oxidation will involve an increase in the oxidation number, and then reduction will involve a decrease in the oxidation number. Okay? Right, and then we also have terms like cathode. I want you to understand when we talk about a cathode, okay, we are talking about an electrode where reduction takes place, right? Cathode, we are talking about an electrode where reduction takes place. And then anode, it's an electrode where oxidation takes place. Let's take note of the two. Right, so there's two types of electrochemical cells, namely galvanic cell and electrolytic cell. Now, number one, you can notice the difference between the two. Let's talk about the general appearance of a galvanic cell and a general appearance of an electrolytic cell. What am I going to expect when it comes to a galvanic cell? Number one, I should have a galvanometer slash voltmeter. Now, you will realize that the reason why they use a galvanometer is because a galvanometer is able to take the smallest readings of a voltmeter compared to a voltmeter, because normally a voltmeter is used in an electric circuit, so it doesn't really give much. So it's much better to use a galvanometer than a voltmeter, but you should expect a voltmeter or a galvanometer. Number two, you're going to have connecting wires, of course, positive and negative, and then you're going to have electrodes. Now, with these electrodes, they could differ from any metal, basically, because if you think about it, a lot of nonmetals are mostly like liquid and gas, so most of the metals are in a solid form. So that's why in most cases you will get electrodes that are mostly metal. Okay, can be anything from zinc to copper, whatever that you can think of, as long as it's a metal. Okay, and then we also have two beakers. Inside these beakers we have an electrolyte, so meaning it's a solution. It's an aqueous solution, to be specific. One would ask, what is an aqueous solution? It's a solution that contains ions, positive and negative ions. Okay, and this particular solution, because it's an electrolyte, it means it can conduct electricity. Is that clear, guys? So in both beakers we have electrolytes. Now I want you to think about this. Say I'm making an example of zinc copper cell. Okay, say I'm making an example of zinc copper cell. One thing that you are going to take note of is that if an electrode, meaning where the wire, because remember the wire is going to be connected to an electrode. So if my electrode is made up of zinc, it means the electrolyte, which is the aqueous solution that I was talking about, is going to be a zinc solution, meaning zinc sulfate, zinc nitrate, whatever that you can think of, as long as we have positive and negative. Obviously, we need to have zinc a solution, because the electrode is made up of what? Of zinc. On the other side, if we have copper, it means inside the beaker we are going to have a copper solution, meaning it can be copper nitrate, copper sulfate, as long as I have positive and negative ions.